So in the last class we've seen Newton's rings. We've seen the different cases of Newton's rings formed from reflected light as well as transmitted light, and we've discussed this apparatus as well, how Newton's rings are formed. And today we will be discussing about different applications of Newton's rings. The first one being the determination of the wavelength of sodium light. With the help of a traveling microscope, measure the diameter of the nth dark ring. Let the diameter of the nth ring be dn. Then dn square equals 4n lambda r. You all already seen this expression for dark ring in the case of reflected light. And the diameter of n plus mth ring can be written as dn plus m square equals 4n plus m lambda r. And subtracting these two equations, we will get dn plus m square minus dn square equals 4m lambda r. Since this 4n lambda r term will get cancelled, the remaining term will be 4m lambda r. From this, lambda can be calculated. So lambda equals dn plus m square minus dn square divided by 4mr. So the next application is the determination of refractive index. Determination of refractive index using Newton's rings. Here, the liquid whose refractive index is to be determined is filled in the gap between the lens and the plain glass plate. So up to now, we had this air film here between the plano-convex lens and the plain glass plate. Now we put some liquid here, some drops of liquid here, the liquid which we want to determine the refractive index. So we put the liquid here. So this will be a liquid film now. Instead of air film, it will be a liquid film. And now the liquid film will substitute the air film, and the condition for interference will be written as for dark ring. For dark ring, the condition will be 2 mu t cos r equals n lambda. And in case of air film, we had taken the refractive index mu as 1 and cos r as 1 for small values of r. But here we have a liquid film in between the plano-convex lens and the plain glass plate. So we keep mu as it is, and cos r again becomes 1 for small values of r. So it becomes 2 mu t equals n lambda. And now, since t, thickness of the film at a particular point, t equals r square upon 2r. This expression we have seen derived in the last class. So substituting the value of t here in this expression, what is small r? Small r is the radius of the dark ring, and capital R is the radius of the plano-convex lens, radius of curvature of the plano-convex lens. Now substituting the value of t here in this expression, this will be 2 mu r square upon 2r. 2 mu instead of t, r square upon 2r equals n lambda. So 2 cancels, and this value of r square can be written as n lambda r upon mu. So again, diameter, in terms of diameter, this becomes d square equals 4n lambda r upon mu. You can just verify this. Now, this is the case when we have a liquid film with refractive index mu in between the plano-convex lens and the plain glass plate. Now, if it was an air film, the mu value becomes 1, and the diameter of n dark ring is dn square equals 4n lambda r. Diameter of n plus m dark ring is 4n plus m lambda r upon 1, since mu is 1 for air film. So this is the case for air film. Just subtracting the above equations, we will get dn plus m square minus dn square as 4m lambda r, where dn is the diameter of the nth dark ring in case of an air film, dn plus m is the diameter of n plus mth dark ring in case of an air film. Now in case of liquid film, only difference is there will be a mu in the denominator, and let the diameter of nth dark ring in the case of liquid film will be dn dash, and then dn dash square can be written as 4 lambda r upon mu, and the diameter of n plus mth dark ring will be dn dash square n plus m, which will be 4 n plus m lambda r upon mu. Again, taking difference or subtracting these two equations, we will get dn n plus m dash square minus dn dash square equals 4m lambda r upon mu. Since this 4n lambda r upon mu term will get cancelled, and the only remaining term will be 4m lambda r upon mu. From these two equations, we divide these two equations, that is the air film case and liquid film case. Dividing these two equations, we will get the value of refractive index as dn plus m square minus dn square upon dn plus m dash square minus dn dash square. So by dividing this term in the numerator 4m lambda r gets cancelled, and the only term remaining will be mu in the numerator after taking reciprocal. So this will be the value of refractive index. Again, this can be determined using graphical method as well. The arrangement, the Newton's rings arrangement, that is the glass plate, plano-convex lens, and the that arrangement is placed in both air and liquid. And the diameter of dark rings are determined for various order in both cases, that is for air film and liquid film. The graph is plotted between dn plus m square versus m, where m is the order of the ring, dark ring. Then the ratio of the slopes of the two lines. Let's see what the ratio of the two lines are. So we plot dn plus m square versus the m order. So for air film, this is the line that we get. If we plot the points, that is for different order, we plot the value of dn plus m square, and this will be for air film, and similarly this will be for the liquid film. Now what will be the slope? Taking the slope between some random points, say 3 and 6, suppose we take the slope between these 2 points, 3 and 6, third order and sixth order. So the slope will be change in y by change in x direction. So the change in y direction will be these points, that is AB, and change in x direction is 6 minus 3, that is 3. So this will be 3. So the slope will be AB upon 3. In case of liquid film, the slope will be A dash B dash upon 3. A dash B dash upon 3. So taking the ratio of the slopes will be AB upon 3 whole divided by A dash B dash upon 3. So this will be, the 3 gets cancelled and remaining term will be AB upon A dash B dash. Hence, we know what AB is. AB is, if suppose point A is some dn plus m square, some value, and point B is some dn square, then the difference will be AB. So this is what we got for refractive index here as well. Both are same. We just put this in a graphical form.